Students, this is week 6, lecture number 2, and in this topic we are going to study the most important part of chapter number 2. In the previous lectures, we studied what is exponential function and logarithmic function, what are the properties of exponential function and logarithmic properties of logarithmic function. Clear? Then we learn some exponential questions, and here we learn the logarithmic questions. But the most important topic that we are going to study today is the conversion. Conversion means how to change exponential function and logarithmic function in each other. But before we learn how to convert exponential function into logarithmic or logarithmic into exponential, we need to understand, we must clear in our mind that both functions are inverses to each other. This is very important property. What this property? Please look here. Both the functions are inverses to each other. So how we are going to do it? Let us consider fx is equal to log x base a, we are considering, and f inverse x is equal to a power x. In composition of function, we learn if two functions are inverses to each other, we will get identity. Clear? So we are starting with f composition f inverse of x is equal to, by the property of composition, it is f of f inverse x. What is the value of f inverse x? It is a power x here, this value. So put the value. Now f of x, we need to put the value here. So log a power x base a, because x is a power x, so x will be replaced by a power x here. So it is log a power x base a. Now x will be shifted here. This is the property in logarithm. So it is x log a base a. Then you remember in the last lecture we learned log of a number with the same base as the number is always equal to 1. So answer is x. So this indicates that f inverse is the inverse of f. This f inverse is the inverse of f because it is equal to x. Okay. So another way you can change their position, f inverse composition f. Here we prove f composition f inverse is x. Now we'll prove f inverse composition f opposite is also equal to x. So by the definition f inverse, now it comes fx. What is the value of fx? Log x base a. So it will be a power x, because here x means x here. Here log a power x, so a power log x base a. Now this cancelled by this. This is the property of logarithm, and it is equal to x. So you take f composition f inverse or you take f inverse composition f. Both are equal to x. So that proves that exponential function and logarithmic function are inverses to each other. This is very important property that you need to remember. And we will change so many exponential function and logarithmic function into each other. Okay, so this is very important, and particularly this relation is very important. These are the properties of logarithmic function and exponential function, basically mixed properties. How we are changing the exponential into logarithmic and logarithmic into exponential. This is the property number 1. If b power c, this is exponential, is equal to a, this is exponential function. So how we are writing? Log of a base b equals to c. So you must notice here base b is both places base. Here b power c, base b, exponent c. Here base b is there, base is not changed. So it is log of the right hand side base b equal to c, or you can write b power c equals to a. This is both way. Clear? So this we learn with examples. Then if y is equal to ln x, natural log, that is log x base e. So how can we write this? X is equal to, you can write this e power y, base power x is equal to base power right hand side. This is same to same this property, and also this is same, x is equal to a power y. So these two are, we are changing logarithmic function into exponential function. Here exponential into logarithmic, here logarithmic into exponential. Okay. If two logarithm function are equal with the same base, then the functions are also equal. X equals to y, like exponential function. And this is the property that I was telling on the before slide when we were talking log a power x base a is x, and similarly e power log x base e, this is e. If it is a both place or if it is e both place, the answer is x. So these are the important properties that we are going to use in this lecture while solving two type of problems. So first type of problem, we are going to study the conversion. Clear? So example number 1, we are going to study convert into logarithmic function. So first type of problem we are going to study is exponential functions are given and you need to write it into logarithmic function. Clear? Okay, like 4 power 2 equals to 16. How to do it? It is very simple. You will take log of this. That means log of 16. I told you base will remain same. Base 4. Answer is equal to 2. This is class. Finish. This is very simple. Log of this number with base this number equals to this number. Okay, let us write the question number 2. 2 power minus 3 is equals to 1 upon 8. How to write it? Log of this number, right hand side, log of 1 upon 8 with base 2 is equal to minus 3. This is equal will be going this number. Let us solve another problem. It is 10 power 2 equals to 100. How we are going to do? This is log of 100. Log of 100 base 10 equals to 2. This is very simple. And if fourth question I take, say 4 power 0 equals to 1. How it is? It is log 1 base 4 equals to 0. So this question is how to change the exponential function into the logarithmic function. And it is very simple. B power c equals to a. This implies log of this. Log of this means log of a. This is the b is the base. Base is same at both places. Is equal to power c. This is how we are changing the exponential function into logarithmic function. Okay. Now the reverse process. Reverse means convert the following into exponential function. Convert the following into exponential function. Question number 1. What it is? Log 32 base 2 equals to 5. Clear? How we are changing? Just let us learn how it is. If log of a base b equals to c, log of a base b equals to c. So how we are changing? This b power c is going this side. B power c and equals to a. So it is equals to this number. And what it is? 2 power 5. Class. This will be a 1 mark question in your midterm, in your final exam. Clear? Okay. Number 2 question let us take is log 81 base 3 equals to 4. How we are going to do? It is, look, it is 3 power 4 is equals to 81. Got it? And one more question, and that will be log of 10,000, log of 10,000 and base 10 is equal to 4. So how much it is? This will come here. 10 power 4 equals to this number, 10,000. Okay, so this is how you are going to change, you are going to convert the exponential function into logarithmic function and logarithmic function into exponential function. For this, if you will go to previous slide, means change it into logarithmic function. This is, you can solve question number 10 over page number 39. There are 5 parts are there, and if you want to solve here, this is question number 11 over page 39. There are 6 parts in this question. You can solve these 2 questions to get expertise in conversion of functions. Okay, now we have some equations, the logarithmic equations, and we need to find the values of x. Clear? And here you need to remember the properties of logarithmic function and as well as exponential function. Then it will be a 2 to 3 marks question in your exam. This is example number 1. We are going to solve. What the question is, if log of x base 3 plus log of 9 base 3 is equal to log of 45 base 3. Clear? Find the value of x. Find x. Okay, so this is the question. And if you remember this property, what was the property? Property was log of x plus log of y is equals to log of xy. In the previous lecture, we studied this property, that log of xy is equal to log of x plus log of y. Or if they are in addition, we can write them in multiplication. So what it is here? Log of xy, x into 9. X into 9 means 9x we can write. And what is the base here? 3 equals to log of 45 base 3. And when 2 logarithms with the same base are equal, what was the property? Log x base a is equal to log y with base a. Then x is equal to y. This is the property. So here 9x equals to 45. And if we divide by 9, so what we'll get? It is 45 upon 9. 9 cancelled by 9. So x is equal to 9 times 5 is 45. So what is the solution of this question? The solution of this question is 5. Okay. Now we will take another question. Another question is, if say log of 2x plus 1 equals to log of 11. This is very simple. Nothing base is written, no base is written. That means base is 10. I explained you in last lecture. What? That log of x is same as log of x base 10. So log, if two log with same base are equal, their function are also equal. 2x plus 1 is, this is 2x plus 1, this is 11. So 2x equals to 11 minus 1, and 2x is equal to 11 minus 1 is 10. Now divide by 2. 2x by 2 is 10 by 2. So 2 cancel. So x is equal to how much? The value is 5. Okay, this is another type of problem. One more thing I want to tell you, this is example number 2. Another example I want to tell you, I told you in previous lecture, if we are studying properties, so the properties related to logarithm or natural logarithm, it is same to same. Only the difference is base. For example, if you will take ln 5x minus 1 equals to ln 2x plus 8. If you see here, ln is written. Ln means what? It is same. Log of 5x minus 1 only with base e. Here base 10 was there, but here base e is there. This is the difference. Log 2x plus 8 base e. So logarithm with base e, logarithm with base e. So what will be? These will be equal. So 5x minus 1 equals to 2x plus 8. Now separate the term, x term one side and constant terms one side. So 5x minus 2x is 3x, 8 plus 1, it is 9. Divide by 3. So 3 cancel, x is equal to how much? The value of x is 3. Got it? This is example number 3. This is another type of problem. Now we will study one more type of question, and the question is example number 4. It is 3 ln 2 plus ln x minus 1 equals to ln 24. If you see, if in another form I want to write, this is 3 log 2 base e plus this is log x minus 1 base e, and this is log 24 base e. If you see this, here it is log, here it is log. So we can use the property what? Log of x plus log of y equals to log of xy. We can use this property, but there is some problem in this property. What is the problem in this property? Because a number 3 is here. This 3 is creating problem for us. Then what can we do? We can use another property. What was the property? If x log a, then this can be written as log a power x. This number can be shifted to power. This is the property of logarithm. So here what we are going to do, it is log 2 power 3 base e plus log x minus 1 base e equals to log 24 base e. Clear? Or this may be right in the form of ln. No problem. Clear? So what it is? Now log, now use this property. It is log 2 power 3 is 8 and x minus 1. Let us write in another form. So log of 8 into x minus 1 base e equals to log 24 base e. Now look, log same base. So these are equal. 8x minus 1 equals to 24. Now multiply inside. 8x minus 8 equals to 24. 8x equals to 24 plus 8. And 8x equals to 24 plus 8 is 32. So divide by 8. It is 8x divide by 8, 32 divide by 8. And 8 cancel. So x is equal to 32 divides 8 is equal to 4. Clear? So this is a very good example, and you must learn this example how I am doing and repeat this at home maybe 3-4 times so that you can understand what is the idea behind this type of question. Okay, now another type of problem we are going to, this is one type of issues. Another type of issues, now we will study 3 questions. Example number 5. One side it is log. Look, in the previous 3 examples, not 4 examples, we have both side log. Left side log, right side log. But in this question, only one side log is there. One side log, another side a constant number. In such cases, change or convert it into exponential function, because this type of questions we studied. If one side log, another side no log. So how we are going to change? This will be 5 power 3. 5 power 3 equals to whatever is written here, 2x plus 3. Or this implies 2x plus 3 equals to 5 power 3 is 5 power 3. It is 125. So this implies 2x is equal to 125 minus 3. This implies 2x is equal to 122. Divide by 2. So x is equal to 122 by 2 and it gives you 61. So what is the answer for x? It is 61. This is one example. One example where we have one side exponential function, one side logarithmic function, another side nothing, a simple constant. Then how we are doing? Okay, this is another question here in the same category, 3x plus 7 and not 3x plus 7, it is 3x minus 5. All questions I am doing the exercise problems. It is given in question number 7 on page 38. All these are exercise problems. You need to practice these questions. If you understand this, you can solve every question. So look, one side log, another side constant number. So change it into exponential function. 4 power 0 is equal to 3x minus 5. This implies 3x minus 5, 4 power 0 is 1. This implies 3x is equal to 1. Shift this minus 5, it will be plus 5. So this implies 3x equals to 6. Divide by 3. 3 cancelled by 3. X is equal to 2. This is. Understand? So this is how we are evaluating the values of x. Example number 6. Example number 7. The same type of question, only little change we are having. X square plus 7. This is base 2 and equals to 4. How we are doing it? Same, one side logarithm, another side constant. So change it into exponential. 2 power 4 equals to x square plus 7. This implies x square plus 7 equals to 2 power 4 is 16. So this implies x square equals to 16 minus 7, and this implies x square 16 minus 7 is 9. So you learn in exponent how to remove this 2, how to remove this power 2. So we need to take a square root of x power 2. And I explained you, if we are taking a square root, we always put plus minus outside it. So root, this 2, root is cancelled. So x is equal to plus minus. What is the value of square root 3? Sorry, square root 9. It is 3. So there are 2 answers for this question. X is equal to plus minus 3. Okay. So we will solve one more question, and the question I have chosen because in this we need to factorize the quadratic polynomial that we get in the solution of the question. So this is the last example we are going to study. This is example number 8 and it is question given log x base 2 plus log x plus 2 base 2 and equals to it is 3. This is. So now there are two log term, one log term, one log term. So it is logarithm x into x plus 2 base 2 is equal to 3. Now if you simplify this, it is log multiply x into x is x power 2 plus 2x base 2 is equal to 3. Now this is one side logarithm function, one side constant. So how we are doing? Changing into exponential. And if we are changing into exponential, so it is x square plus 2x is equal to this 2 power 3. And 2 power 3 is 8. So it is x square plus 2x taking this side 8. And if you remember, this is a quadratic equation. This is a quadratic equation. And how to solve it? You can solve it using quadratic formula. X equals to minus b plus minus b square minus 4ac upon 2a. And what is the value of b? It is 2 plus minus b 2 power 2 minus 4. The value of a is 1. The value of c is minus 8 upon 2 into 1. So it is minus 2 plus minus 2 power 2 is 4 minus minus plus and 8 times 4 is 32 upon 2. So minus 2 plus minus 32 plus 4 is 36 and the square root of 36 is how much? 6 upon 2. Now you need to choose minus 2 plus 6 upon 2 and minus 2 minus 6 upon 2. So this is how much? 6 minus 2, it is 4 upon 2 and minus 2 minus 6, it is minus 8 upon 2. So 4 upon 2 is 2, minus 8 upon 2 is minus 4. So these are the two values of x for which this equation is possible. So x is equal to 2 and minus 4. This is really a good example, good question that you need to study, because so many questions we need to practice so that we can get good marks. Clear? But I'm 100% sure this type of question means we have studied how many? Look, 1, 2, 3, 4, 5, 6, 7 and 8. We have solved 8 questions, and if you practice these 8 questions, I'm 100% sure you will succeed. Thank you very much. And one more thing I want to tell you, now we remaining 2 topics. One, how to graph the logarithmic function, and what is the application of logarithmic and exponential function. That we will study next week. Thank you very much. Take care. Masalama.